So this is recording right now. Yes. My goal for today was just to do a simulation. And I'm gonna. I've got two screens, and this is when I look at you, but then I look at my programming screen. Now I'm really looking at you, but then it seems like I'm not looking at you, but I'm actually looking at you. Uh, my goal is just to do two very simple simulations, and I made a paper as well, like the one I asked you to make. And the first one I'm gonna do is a growing snowflake simulation. So I've got so that's an agent-based one, and I got agents, and when they get close to a central agent which is standing still, they stick. So that's like the simplest thing you can imagine for agent-based one. And I'm doing that just to show how you can start, basically, because maybe some of you have some problem in starting up. So I'm just gonna program, basically. And if at one time you think, well, this is all boring and too slow, please let me know. Or if you think, well, it's boring and slow, but for the rest it's probably interesting, you can also log off if you don't think it's suitable for you. So does everybody understand the first one I'm gonna do? It's agent based. I've got particles, and when they get close to a central one, they're gonna stick. That's all. So it's a pretty simple situation. And the first thing basically we have to do, we'll probably need NumPy, right? So that's probably a useful thing to use as well. Maybe we also want to make graphs. That's probably a nice idea as well. But that's all the standard stuff, right? The first thing we have to think about, what is the things we need. So we have particles, and when they get close to one central point, they're gonna stick. If they get close to a central particle, they're gonna stick. But if they get close to another already sticked particle, they're gonna stop as well. So what kind of things do we need to keep track of for each particle? So what kind of administration do we want? So basically, what is the thing here in the bottom? Can somebody shout already something?
The speed.
The speed, yeah. It's a good idea to have a speed to have the speed straight away in a x and a y direction. Because basically, you can of course do like speed in the magnitude and the rotation, but it's actually easier to do just the speed in the x and the speed in the y direction. I'm gonna make an array of. I'm gonna start with 0 speeds. What is a smart way to put? Does everybody understand what I'm doing right now? That this is an array. The MP0s, I'm making an array. So I'm not making only Vx, I'm making actually a lot of Vx's. How many Vx's am I making right now? Your name is Jacob. How many am I making right now?
I think you mean us.
Yeah.
You could outside the screen for a second. I'd say for the length of how long you want to run your, like how many time steps you want in your simulation.
Yeah, that's already a good question. I want to keep track of the speed. Do I want to do that per time or per agent? What seems like a smart choice?
This is per agent, right?
I think per agent.
Yeah, I think so too. So I probably need to define some way the amount of agents I'm going to do, right? And so basically now, let's see what I made. I made an arithmetic error. Okay, that's interesting. So let's see what I made. I just made an array with all zeros. You see? And if I want to put something in some position of the array, let's say the first position, I want to start it with speed 10, and then I have to do something like this. Can I just put in a 10 here? You see? Okay. So I need also the position, the speeds in the y direction. What more do I need to keep track of for each agent?
State.
Position.
Sorry, again?
Position.
Position.
I hear distance and I hear something else.
Position.
Yeah, this distance is interesting, but the distance to what, Bastiaan?
To each other.
Yeah, but that's something which you have to calculate each time. So I'm not going to do distance. I'm just going to do only position. It is an interesting question if I should do distance also, but I'm just going to do position. Okay, so now I got for each edge, and I'm going to do it like this. It's in my head a little bit more logical. So I got the x position, y position, the speed in the x direction, and the speed in the y direction. And is it clear? Am I clear? Am I easy to follow or not? Because there's a lot of background noise here. But is it okay or? Okay.
Fine.
Okay.
Yeah, it's okay.
I need one thing more, which I want to keep track of each agent. The problem is, if I've got a snowflake, when it's not moving anymore, I don't want moving snowflakes to collide. I only want a moving snowflake to collide with a standing still snowflake. I can make it different. I can say also, well, I want a moving snowflakes to collide as well. But in this case, I just want to make like that only they can collide with one central, with all the snowflakes which are standing still. So then I need to have some kind of
Status.
yeah, exactly. Yeah, that's exactly what I was thinking about. And this is not. This is one way to do it. There's a lot of different ways to do this. I can also program it differently. Like, well, I'm gonna check if the speed of the snowflake is really 0, etc., etc. But I like the status thing because I can use it for more stuff. So I'm just gonna put status. Okay. I'm gonna. The status. Oh, I'm gonna put somebody a little bit on mute, I think. Or is it? No, it's okay. Yeah. Just as a comment, 0 is not started in my case, and I'm just making it up. It's just what I think is nice. Let's say 1 is active, and let's say 2 is sticked. Sticked to the big snowflake. So that's something just which I made for myself. Like, okay, this is the statuses I came up with in my head. What would be a nice next step? Well, I could look at my paper and then I see that I got like first one big loop. So I'm gonna make a big loop. What could be the purpose of the one big loop? There's a lot of stuff which you want to do each and every time. So what is probably the purpose of that? Sorry?
Time.
Yeah, time. Yeah. Let's say, and I just want to have it run, I don't know, 10,000 times, something like that.
I have one question. Sometimes you use a for loop for this, but you can also use like a while loop, right?
Yeah. Yeah.
Why would you use one of those? Is there a difference or?
Yeah. The nice thing of while is that you can have more stopping conditions. So in this case, the loop only stops if the t is 10,000. But if you want to have something else to make it stop, then the while is much nicer.
Right.
While is a lot of times really nice. The advantage of for is that it's you have to type a little bit less because like the incrementing of the t, it does it automatically. T becomes one bigger each time. That's easy.
But if your simulation isn't right, it can go forever, right? With a while.
Yeah, true. Yeah. But you can still with this one, with restart kernel, you can always stop it, Nino. So sometimes you cannot stop it with this red thing anymore, but you still can stop it with restart kernel normally. Is it readable, the lines of code?
Yeah, it's fine.
What would then I want to have an extra loop? What kind of a loop should it be? What do I want to loop now?
Active.
Sorry?
Snowflake? The active snowflakes? Or
Yeah,
the
I wanna loop through my agents, right? I wanna know for each, you're right, you wanna loop for the active agents, but basically I'm first gonna loop through for my agents. I'm gonna pick I. I don't know if that's the best choice. In this case, I is just a number, eh? It's not an agent or something. And I'm gonna do something like this. Max agents, right? Okay. And then you said, well, I want to do it only for the active agents, right? So 1. Is everybody on board what I'm doing here? Yeah, the SF, not not the SFDF, but this thing. So I'm looping for I to all the values of, well, that's basically from 0 to max agents, or max agents minus 1, I think. And then I'm just checking if the status is equal to 1. Does everybody understand that? Or who has questions on this? Now, Eric wants a coffee, but he doesn't have a question. Okay. Okay. Did somebody have a question? No? Okay. So what should I do for each agent? And I can do, there's 2 things which I have to do for each part of the snowflake, for each mini snowflake. I have to see if it sticks, right? So I have to see if it's close enough to another still standing snowflake. But there's one other thing I need to do. Does anybody have an idea?
They need to move.
Yeah, they need to move. And I can do first the sticking and then the moving, or I can do first the moving and then the sticking. Is it different? Yeah, a little bit. Does it really matter right now? No, not really. But it could be that the result is a little bit different. Now I'm just first going to do the moving. Does anybody have an idea how I should do the move?
I'd say that you need a direction and a speed to know in which way you're moving.
Yeah, the nice thing is that I actually don't need the direction. Why don't I need does anybody have an idea why I don't need the direction?
Because we're working with XY coordinates.
Yeah.
So you could say they move to right and to up, or in
no,
something
basically I've got it all covered in this Vx and this Vy.
Okay.
The combination of this gives the direction, David. But basically, that's why it's nice to have it only in Vx and Vy. I don't care about the direction. That's already incorporated in the fact that I've got a speed component in the x direction and in the y direction. Y and x. And it can be, if this number, it's going to be like this. If it's negative, it's going to be like this. Positive like this, etc. I don't care. Agree?
Okay. Yes, I agree.
So that's the nice thing why I did it from the beginning in. So
yeah, okay, I understand.
Still a direction, right?
Sorry?
That is still a direction, right?
Well, the combination of those two is a direction.
Yeah, but if you go in the x side, that is the direction then, right? So
yeah. So what kind of rules do I need to type in now? How does, when you are driving on a highway, Nino, and you know your speed, 100 kilometers per hour, what is your new position depending on the old position?
the difference, or
Yeah, close.
the new position, yeah, and the time.
Yeah, something like that. So in this case, I'm gonna do a little bit strange here. In this case, I'm gonna do it the updating per agent. This means that really I move one agent and then I move the next and then I move the next. That can be that you don't like that. It can be that you want to first move all the agents and then do the next steps. Here I'm gonna move an agent, check if it's close by, and then go to the other agent. If I do it like this, I don't have to worry about the old and the new position, because this is the old position, right? And this is per definition then the new position. If I do want to have that Unterschied, the difference, if I want to know what the old and the new is, and that I really want to move all of them simultaneously, then I need to do something like new pos and old pos and stuff like that. In this case, I don't mind. What should I type now?
Lost the speed in X.
With the speed something, and I want to have that speed of that particle, right? So I have to do like this. That's the speed of that specific particle. And I could still, is it times dt? But then I don't have a dt yet, so I have to make a dt. Elapsed time. So this looks okay, right? Okay. I'm gonna do the same thing for y.
Please. Yeah. Ask it.
Yeah, ask it.
Is a dot equivalent to multiplying?
Oh, no, it isn't. It should be this, or not. I don't know, actually. What is multiplying in Python? Is that this?
Yeah, it's this.
Okay, okay. Yeah, you can use a dot, but it's totally different. Sorry. Okay. So we just check if the particles are moving or not. Is that an idea? It's nice,
Yeah,
yeah.
sure.
And then I'm gonna use a trick. Oh, there's a lot of noise on the. Okay. I'm gonna use a trick. I don't wanna have the position of the particles on each and every time step. Do you know why I don't wanna see the position on each and every time step? Does anybody have an idea?
Is too much? Or?
Yeah, it's gonna be very, very slow, because the plotting takes a lot of time. So I'm gonna use a trick. Let's say, does everybody know what this means?
No.
Okay, this means divide by 10 and look at the rest. It's modulo. So t is divided by 10 and look at the rest. And if the rest is 0, is 0, then I want to do something. This means if t is 1, nothing happens. 2, nothing happens. If t is 10, something happens, because then the rest is 0. If t is 20, something happens. If t is 30, something happens. So this is a nice way to only do something in 1 or 10, or if I do it like this, 1 in 100. Yeah? Everybody connected? Okay. Let's see. And I wanna, how am I gonna show? Yeah, I'm just gonna show it. And then I need to. Shall we run it? Is this gonna work? Does anybody have an idea? Nino's going, well, could be, I don't know.
No, it doesn't work.
Yeah, why not?
Yeah, you have no velocity.
Yeah, I've got no velocity, and also I don't have. None of the agent is active, right? So all the agents just stay in 0. Well, that's what you expect. Okay, so let's give agent. I want to have one agent. I want to put it in the middle. And what is the middle? I'm defining 5,5 as the middle, and I want to have that agent. I want to have a 2, so it's not sticking. Oh, it's sticked already. And I'm gonna give another particle a starting speed. So the second particle I'm gonna give starting speed, and I need to change that status as well. 1. Why does this? Hey, my status is gone. Oh, okay. Oh shit! I put them here. Okay. Is this gonna work, Tycho? Let's see.
You don't know where it starts yet.
Sorry?
You don't know where it starts yet.
Yeah, let's see what happens. Well, something is going good, something is going bad. Anybody has ideas?
The agent is past the 5.5, but not in touch.
It's
So
it's just gonna travel, keep traveling, right? How can we fix that?
by checking if it's touching or the distance, and then stop the movement of Vx and Vi.
Yeah, that's true. I need to incorporate the sticking, But the other problem is if I miss the particle, I'm just gonna go to Valhalla, right? It's just gonna keep on moving. So what I'm gonna do in this case, I'm gonna make a box where I want where the particles are bouncing. So they're bouncing from left to right, etc. You see what I mean? So the boundaries of the box are gonna be 0 and 10, 10. That means if x, y is, for instance, smaller than 0, or x, I is bigger than 10, what should I do then? What is the smart when it reaches the border? What's if it's going like this and it reaches the border of my screen, then it should go back. What should I do then?
So speed is fine, -1.
Yeah, the speed. I have to change the speed, and I'm just gonna make the speed negative. And I don't care if it's going wrong this side or this side. I'm just gonna change the speed. Is that a smart idea?
Yeah.
Okay. Okay. I'm gonna do the same for Y. And I'm gonna stop the recording for a moment and restart.